Now we're at section 1.5, exercise 22. And in exercise 22, they're just saying find the vertical asymptotes. So we have this, in this case, h of x equals x squared minus 9 over x to the fourth minus 2x cubed minus 9x squared plus 18x. And so immediately I can see that I could factor out an x out of the bottom of this thing, and so, you know, this is x squared minus 9 over x times x cubed minus 2x squared minus 9x plus 18. And as I look at that, well then x equals 0 looks like a vertical asymptote, and the reason is right, at x equals 0 it looks like minus 9 over 0. Now, you know, what about anything else? Well, this bottom has at least one 0 because it's a cubic. And you know, now one of those zeros could be either at 3 or negative 3, which is the top of this, and then I would have some removable singularity or removable discontinuity at that spot. You know, but beyond that, I don't know. You know, so I could spend time trying to factor this thing, and you know, I can check, you know, I can do things like synthetic division or long division, or I could actually just evaluate 3 and negative 3 in here. So, you know, let's just look at that. You know, we're here to do more than just calculus. You know, suppose I let x equal 3, then this bottom part, don't worry about the x. I'm just wondering, do I get 0 on the bottom here? And if I do, well then I have a removable singularity or a removable discontinuity. If I don't get 0 on the bottom, well the bottom's not 0, so there's not a problem. And so at x equals 3, I see that, you know, I've got 3 cubed minus 2 times 3 squared minus 9 times 3 plus 18. Okay. So 3 cubed minus 9 times 3, oops, sorry about that, that's 27, that's negative 27. And then here I see that I have 9 times 2 is 18, oh yeah, this equals 0. And so well actually I don't know for a fact that it's a removable singularity. What I know is that x minus 3 is a factor, but it could be that x minus 3 quantity squared is a factor. In other words, x minus 3 goes into this polynomial more than once. And so, you know, I could divide by the x minus 3, factor that out, figure out what I have there, and then keep going. I could do the same thing with x equal negative 3 and plug that in and so forth. So I can do things analytically like that, but at the same time I do have this wonderful graphing calculator, and so I'm gonna go there, and it take me a minute to plug this thing in. But I'll go ahead and say f of x. I don't have to, but I don't know, I just like it because then we can use it in other ways to evaluate things if we want. F of x equals, and again we had on the top x squared minus 9, so x squared minus 9. Now I'm just kind of trying to see what I can do with this tablet and so forth. I'm kind of wondering if I highlight that whole thing. No, I can't seem to do that. So I'll put a parenthesis around it here and then say divide. And on the bottom I had x to the fourth. Well, so that's a to the b, so I'll do that, and then 4, and move that way, and then what, minus 2x cubed, and then minus 9x squared and plus 18x. So I do that, and of course, see, I can see my asymptote here at x equals 0. There is no asymptote at x equal -3. Nothing there, so that appears to be a removable singularity. Well, it's not 0, so yes, I'm pretty sure it's a removable singularity. Yeah, as I kind of move over there, undefined. And so what I think is the case then is that the bottom is equal to, so here I'm going to do this just to check things out. I'm going to do a g of x. G of x equals, and so I'm going to take x and then times x minus 3, so x minus 3 squared, and then times x plus 3, x plus 3. Now, see, I think that's the denominator in f of x, and so now if I just look at the function of x squared minus 9 divided by g of x, there's g of x. Oh, well, interesting. Okay, it's not quite the same. I'm going to turn that off by, what's going on here? I'm not sure. Well, I don't know if I can turn that off. Oh, there, I finally got it. Interesting. Okay, so see, I checked something out. I thought maybe I had the same function, but I don't. So I don't want that function anymore. And now, actually, after I look at this f of x, so let's I thought there was an asymptote at 3, but now actually, again, you should have yelled at the video or something. Hopefully you did. I see, here's the 0, but notice the 3 or -3, neither one is an asymptote there. The asymptote is actually here at 2. Okay, so the asymptote appears to be at 2. Now I can check that simply by asking what's f of 2. And it should be undefined if there's that asymptote there. So f of 2, and it is undefined. So, so much for trying to outsmart the book problem. It turns out that the bottom does have a factor of x minus 3. But again, that's removable. So, if I come back in here and backspace, so I have g of x there, and then I'm going to toss in times x minus 2. So I guess that's how that cubic factored, plus the x out there, so for the quartic. And so now, if I do my x squared minus 9 divided by g of x, now notice that this function is right on top of the blue function. So, it turned out that, there we go, it turned out that the denominator factored this way. When I first looked at it, I just didn't read the graph very well. I thought that asymptote was at 3, but it was actually at 2. And so we had this thing, the denominator factored this way. And so we actually had removable singularities or removable discontinuities at 3 and negative 3, but then vertical asymptote here at 2 and one at 0 that we found right away. Okay, so that found our vertical asymptotes for what was that, number 22.